This week on WDD's HotSpot. There are plenty of stories about robots exhibiting self-awareness or being programmed to cook, serve drinks, or scout out war zones. But here's the reality of it all. Robots can't even assemble an Ikea chair. Neither can I, but that's not the point. According to MIT, a team at the Nanyang Technological University in Singapore has set out to program a robot to do just that. Were they successful? The robot in question consisted of two arms capable of 6-axis motion, each equipped with parallel grippers to pick up objects. The grippers also had force sensors to determine how strongly they were gripping and how powerfully they could push objects into contact with each other. The robot also had a vision system consisting of 6 cameras that could track up to 5 objects with a positional accuracy of around 3 millimeters. The team broke down the job of chair assembly into various subtasks. One of these was the insertion of a small wooden cylinder into a hole in another stick of wood. This activity itself was made up of 3 tasks. First, one arm had to locate and pick up the dowel. Next, the other arm had to locate and pick up the wooden stick. And lastly, the robot had to locate the hole and insert the dowel into it. Of course, the robot immediately ran into a number of problems, like the fact that the dowel was only a few millimeters in size, too close to the vision system's limit of positional accuracy. Eventually, the team did resolve the issue, successfully programming the bot to insert the dowel, but that's far from building the entire chair. The researchers, however, say they are determined to continue working on the project until all assembly tasks are completed. In the meantime, fret not about artificial intelligence.
A student at the University of London is currently developing a smart glove that converts sign language into text and spoken dialogue, in hopes of opening the lines of communication for people with hearing and speech disabilities. The sign language glove is a wearable device that features a handful of sensors to convert hand and finger movements into words. The student is also looking into adding real-time language translation in the near future. The third iteration of the smart glove is equipped with 5 flex sensors to monitor the bends and curves of each finger and an accelerometer to detect the orientation of the glove. The first experimental version took signs and turned them into visual letters on a screen. The improved model was faster and more robust, featuring smaller, more discrete hardware and text that scrolled on a screen. The latest model features a text-to-speech chip with the hardware sewn into the lining of the glove. The student is now hard at work integrating Wi-Fi into the glove so that its motions can be relayed wirelessly to smartphones or tablets, where an app would handle the translation, in addition to a motion sensor for better mapping and even a smaller version for children. She hopes that schools and businesses will buy them for students, patients, and employees with hearing and speech impairments.
It's an all too familiar scenario. You wake up at 2 o'clock in the morning wondering how many hours you have left to sleep. You fumble around in the dark for where you stashed your phone when you accidentally knock it off your nightstand. Now you have to get up, you probably woke up the dog, maybe the phone screen is broken, chaos ensues. But now, with the DreamMe device and app, you can keep up to date with the time and other information right on the ceiling of your bedroom. DreamMe hardware does not require batteries or annoying syncing to your smartphone or tablet. Rather, it uses a special optical system to magnify and focus the information from your phone right onto the ceiling of your darkened room. While the phone is charging on the nightstand, DreamMe uses it to project parts of the display onto the ceiling, such as local or international time and weather, unread mail, tweets, or your own message. The app ensures proper placement and allows you to choose exactly what it is you want to display. It even provides help for those of you who like to count sheep to fall asleep. And best of all, the DreamMe's stylish cylindrical design is easily adjustable, so you can bring the information to perfect focus depending on the height of your room. You can check out the device on its Indiegogo page.
Pilots need realistic training at a low cost and risk, of course. NASA is developing a technology called fused reality, which uses a special headset that combines real flying in a real aircraft with an overlaid simulation. Fused reality was named for its inventor, Ed, the technical director at Systems Technology Incorporated of Hawthorne, California. The systems work like augmented reality glasses, like Google Glass or digital pilot goggles, by combining the real world with interactive computer graphics inside the viewer of the headset. The result is a view of the area around the plane that mixes the actual scene with computer-generated elements that allow the trainee to practice complicated exercises, such as runway landing at altitude, formation flying, and tracking an aerial refueling drogue without interfering with the regular operations of the aircraft. NASA sees fused reality as having applications not only in training, but also in evaluating new aircraft by allowing test pilots to gain hands-on experience of new configurations, aircraft's control algorithms, and displays under actual conditions without the immediate need for the experimental aircraft. It may also find applications in astronaut training and carrier landing practice. The fused reality technology, which has already begun testing, will undergo even further testing next March at the Air Force Test Pilot School's Test Management Program, where pilots will design a flight test using a Beechcraft King Air C-12 light aircraft. That's all for this week's episode. Be sure to check in on Facebook and Twitter and catch past episodes on wirelessdesignmag.com. For the WDD channel, I'm Janine Mooney. Thanks for watching.
That's a wrap.
Woo!
You're doing really well.